The 2018 AS Maths paper, question 8. A lorry is driven between London and Newcastle. In a simple model, the cost of the journey C pounds when the lorry is driven at a steady speed of V kilometres per hour is C is equal to 1500 over V at 2V over 11 at 60. Find, according to this model, the value of V that minimises the cost of this journey. So the key word here is minimises. As soon as I see this, I'm looking at minimum or maximum points. I've got to be thinking of differentiation. So the first thing I'm going to do is I don't like the V on the bottom, so I'm going to rewrite this. So A part 1, we've got C is equal to 1500 V to the minus 1, add 2V over 11, add 60. So we're going to differentiate. So dC dV is equal to minus 1500 V to the minus 2, add 2 over 11, and the 60 disappears. Now, if we're looking for where it minimises the cost, that is where dC dV is equal to 0. So I've got 0 equals minus 1500 over V squared minus 2 over 11. So therefore we've got, sorry, there shouldn't be a minus, should it? That should be a plus. There we go, sorry about that. So therefore we take the 1500 over V squared over to the other side, 2 over 11, and then we end up with 16500 is equal to 2V squared. V squared is 8250, and V has a value of 90.83. So we've got a value of V there. Part 2, find the minimum cost of the journey. Now, in order to do that, all we do is we sub our value of V into our equation. So C is equal to 1500 over 90.83. Add 2 lots of 90.83 over 11, add 60. So putting that into the calculator gives us a value of C is equal to 93.03. And then we can look at part B. Prove by using d squared c dv squared that the cost is minimised at the speed found in A part 1. So we need to do our second order differential. So we've got d squared c over dv squared. So this is just differentiating our previous differential. So if we've got minus 1500 v to the minus 2, the minus 2 comes to the front, and so times that gives you a positive 3000. Then we take 1 off the power, so we've got 3000 v to the minus 3, and then the 2/11 is just going to disappear, so that's our answer. So what we then have to do is we say, right, okay, d squared c over dv squared is going to be 3000 over v cubed, and we sub in our value of v, so our 90.83. 3000 over 90.83 cubed, and that is going to give us a value of 33.03. Now, as 33.03 is greater than 0, that tells us that V is a minimum value. If it were less than 0, then it would be a maximum value, and if it were equal to 0, then it would be a point of inflection, but as it's greater than 0, it's got to be a minimum. Part C, state one limitation of this model. Well, quite obviously, you wouldn't expect to be able to drive at that constant speed for the entire journey.